Hello students, Miss Slyman here with your 5.7 notes. So this is on the sine and cosine functions and what they look like, and all of this comes from the unit circle, and it goes back to the Ferris wheel that we were looking at today. So the idea with sine is that we're looking at the up-down movement, and so if we start with looking at, on the x-axis is theta, and on the y-axis is the height of the points on the circle. So if we're going from 0 to 360, so we've got 0 here, 360 somewhere down here. At 0 degrees, the height is my y-coordinate. At 0 degrees, the y-coordinate is 0. So I can put 0. And then if I look at 30 degrees, here, my y value is this height. So if I trace that over, then at 30 degrees I'm here. At 45 degrees, I've got a y value here. That's going to put me about here. 60 degrees, I'm up a little bit higher. I can trace that y value. So here's the 60, trace it over, and get me a little bit higher. And then at 90 degrees, I'm up at 1, and then I'm going to start going back down following my y's, and it's going to be symmetric. So there's my 120, and then 135, 150, 180, I'm back to here. Clearly I did not space my graph out very well, so I'm going to have to shoot my 360 over. And it's going to keep going. So down, and then symmetric as I get down, symmetric back up, and back up. So if I connect with a smooth curve, the sine graph is looking at my y values. So let's go back and label the x-axis. My 360, I had to move down here. 180 is here. And then I could have put in my other ones. 30, 45, 90 is my halfway point. I skipped over 60 in the middle there. Clearly, I should have been a bit more careful. So let's do that more carefully. So if my angle continued 360 to 720, it's just going to be another cycle. And if I went negative 360 to 0, that's following the circle in the negative direction. So if I had come with my angles around this way, then at negative 30, I would have been down. So that would have been over here. And I would have continued coming down and then back up again, and then up, and then back down at negative 360. So that portion is a reflection over the y-axis. I would take this and reflect it over the y. So this bit, reflection over y-axis. Why does it have a curved shape? This one's interesting to think about. The curved shape comes from my circle. So the height is not increasing at a constant rate. It increases at an increasing rate and then decreases slowly. So if I increased at a constant rate, I would have had a straight line up, not a curve. So that explains that one. Is it a function? Well, yes, it passes the vertical line test. So for every x value, there's only one y value. Domain and range. So domain, remember the domain, our x value, we're really thinking of theta. So x is an element of real. I can plug in any number for my angle. My y values are my range. I'm never going to be bigger than 1 or smaller than negative 1. Okay, so now we can make this look better. Okay, let's put in negative 4 pi, positive 4 pi, 2 pi, negative 2 pi, pi, 3 pi. Same thing over here. Okay, so I know that at 0 degrees, sine is 0. I know that at pi, it's back to 0. 2 pi is back to 0, 3 pi, 4 pi back to 0. So I'm going to start by labeling my zeros. At pi over 2, I've got my maximum. That's going to be up at 1. So I'm going to put in my 1 and my negative 1. So pi over 2 is where I have my maximum. 3 pi over 2 is my minimum. And those alternate. Over here I'll have minimum, maximum, minimum, maximum. And now I just want to try and draw as smooth of a curve as I can. Try not to have corners. Okay. Try also to reach your maximum points. Okay, cosine, we're looking at our left-right value. So we're now looking at our x value. We're looking at this distance, horizontal distance. So our first distance is going to be 1. I'll try and be a bit more symmetric here. Our next distance, we're coming in. That's root 3 over 2. That's like 0.86 or so. 45 degrees, root 2 over 2, that's 0.7. 60 degrees, I've got my x distance of 1/2. That's here. I'm going to continue down until I get to 180. That distance is negative 1. So at 90 degrees, I'm going to be at 0. And then I start going negative direction. So I'm looking at negative 1/2. And then 0.7, 0.8, negative 1. And I'm going to continue on symmetrically. So I've got 360 degrees here. My halfway point is 180. 90 degrees is when I'm at 0. 270 is my other 0. This is the same, exact same as with sine. We'd have another cycle. And we'd have reflection over the y-axis. It has a curved shape, again, because my x distance isn't moving at a consistent rate. Notice I have my first x distance of 1, and then 0.8, and then 0.7, and then 1/2, and then to 0. So those are not happening at the same rate. It happens slowly and then quickly, and then slowly. Okay, definitely a function. Same domain and range. X's can be anything. I can put in any angle, but the y values are going to be between 1 and negative 1. My graph, very similar to cosine, but shifted. Ooh, let's try and make a straight line. Okay, so 4 pi, 3 pi, 2 pi, pi, negative, of course, pi, 2 pi, 3 pi, 4 pi. We start with cosine at 1, and at 2 pi we're back up at 1. At pi we're at negative 1, negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. And again, try and make a smooth graph.
Mr. Victors, can you borrow a tape for a second?
There we go. Okay. So if I think about transformations and think back into f of x when we talked about the transformation of y. So remember we talked about y equals a f of b of x minus c plus d. We've got the exact same thing. So a is a vertical stretch. So this changes the amplitude. B is in here. And remember, this is the order we do it. We do them in alphabetical order. B is a horizontal shrink. And B changes the period. So a normal period is 2 pi for either sine or cosine graph. And if we've shrunk our graph by a factor of b, then 2 pi divided by b gives us our new period. So the new period is 2 pi divided by b. C is a horizontal shift. Remember, we move in the opposite direction. So if we have minus 30, then we move 30 degrees to the right. If it's plus 30, 30 degrees to the left. Plus D is a vertical shift. We move up and down. This changes the principal axis. So notice for both of our graphs, for cosine, the principal axis is right at y equals 0. And if I have a d value in my equation, then I'm moving that principal axis up or down. So we take our amplitude, we multiply it by 3. Our period stays the same because we have no b value, so the period is going to be 2 pi for this graph. Vertical translation, we're moving up 1. Phase shift, this is the same as a horizontal shift. So we have none in this graph. Okay, let's actually think about amplitude, period, vertical translation for each of for the original graph. So notice here that our amplitude is here. So amplitude is 1. Principal axis. Principal axis is y equals 0. Period. Distance between peaks, 2 pi. And phase shift means how far are we from where we originally start. So right now our phase shift is 0 because we start at 0, we stay at 0. So let's look at this graph before we look at the rest of the table. All right, so we said we've got our normal sine graph. Let me do this in black. So normal sine graph starts at 0, goes up, down, up, down, up. So notice that I'm not so picky with what it's going to look like. You just need to label it correctly. So normal sine graph 0, 2 pi, 4 pi. Okay, normal sine graph has an amplitude of 1, but now our amplitude is 3. So we need to go 3 as our height. And I meant to be highlighting there. So 3 is our height. But it's 3 up from the center. Our center has been shifted up. So if we think about what we're doing, we've taken a graph and we're stretching it so that this distance is now 3. and then we want to move the whole thing up. So if we move the whole thing up by 1, then this line is now up 1. So everything has been moved up 1. That means since this distance is 3, I'm up to 4. My minimum value is at -2. That must mean that my x-axis is around here. So there's my x-axis. Here's my y-axis. So I have a height of 3, amplitude of 3, and I've been moved up 1. Okay. My amplitude is going to be 2. I'm multiplying 1 by 2. Period gets divided by 2, so now it's going to be pi. And that's because of this b value here. I'm moving down 3. And I have no phase shift. So let's go look at this. So I often think it's easiest to start by thinking of where your principal axis is. So our principal axis is down 3. So here, my principal axis is at -3. And now my amplitude goes up 2 from there and down 2. So up 2, that puts us at -1, down 2. So I'm thinking of my minimum and maximum values. Down 2 is putting me at -5. That means my x-axis is way up here. Cosine graph starts at its peak. So we start at the furthest value. So I'm starting up top, and then I come into the center, and then I come down to my minimum, up to the center, up to my peak. So that's one cycle. And now we've said that one cycle is happening 2 pi divided by 2. So I know that I can label this x-axis as pi. And I'm going to do the same thing. I'll come down to my minimum, back up to my maximum, and that's going to happen at 2 pi. So one full cycle is happening at pi. 2 full cycles are happening at 2 pi. So wait to label your x-axis until after you've drawn your graph and thought about your period. So we've got a period of pi. You can also think about the 2 as telling you how many cycles you have in a total of 2 pi. So we have 2 full cycles in 2 pi. Okay, so let's actually go back to the chart. All right, amplitude is 5. Period, my b value is 1, so period is going to be 2 pi. Vertical translation, I'm going to go up 1. That's my d value. Now I've got a phase shift, so my graph is being moved to the right by pi over 4. So if I think about this graph, because my period is still 2 pi, but I've been moved to the right by pi over 4, that means that one full cycle is going to be 2 pi plus pi over 4. So when I draw my graph, I'm not going to draw in my x-axis first. I am going to draw in that I've moved up 1. So my principal axis is at 1. And then my amplitude tells me to go up 5 and down 5 from that. So this time I'm going to be counting by ones. 1, 2, 3, 4, 5. That's here. So I've gone up 5. I'm now at 6. Down 5 is going to put me at -4. I've got my x-axis I can draw in. Okay. And now sine graph starts at on the principal axis and then goes up to its maximum and down. So I'm going to draw that. So I'm going to start at my principal axis. I'll go up to the max. I'll come back down. I'm trying to make this, I'm sort of eyeballing the symmetry, but I went 1, 2, 3, 1, 2, 3, so I should be about here. 1, 2, 3, to come down to my minimum value. 1, 2, 3, to come back up. 1, 2, 3, come back to my maximum. 1, 2, 3, down to my minimum. That wasn't 3, that's 3. Not minimum, sorry, the principal axis. 1, 2, 3, to go down to the minimum. 1, 2, 3, to come back. Okay, so now I know that this total distance from here to here is 2 pi. I didn't actually want to draw that in. I wanted to highlight that. Okay, so distance is 2 pi, or I could go distance from here to here is 2 pi, but I started at pi over 4. That's what this says. So when I go in to label my x-axis, I'm starting at pi over 4. That means when I add my pi over 2, that's going to be pi over 4 plus pi over 2. That'll be 3 pi over 4. And down to where I repeat, I've got 2 pi plus pi over 4. That'll be 9 pi over 4. I'm going to add another 2 pi to that. That's going to give me 17 pi over 4 because I added 8 pi over 4 to it. So this total distance here, here to here, is a distance of 2 pi. And same thing, here to here is a distance of 2 pi. So I can make my nice smooth graph. And then if I were going to come back in and put my y-axis in, it would be over here. So I could think of my graph continuing 1, 2, pi over 4, my y-axis wouldn't have been that far over because I did every 3 lines was a pi over 2 shift. So let's come back, make sure that this says 6, and my pi over 2 would be 1.5 away. I was sort of close there. So that would be my 0 for my y-axis. So I knew that 3 boxes, 1, 2, 3, was pi over 2. So pi over 4 is 1.5 boxes over to make my y-axis. And of course, here's my x-axis. Okay, so this one, we've got a lot of things going on. We've got an amplitude of 6. That's my a value. 2 pi divided by 1/2, that's 4 pi. So again, remember, our period is 2 pi divided by b. Our amplitude is the a value. Vertical translation is d. Phase shift is the c value. So d, we're moving down 2, and we're moving left 2 pi over 3. 2 pi over 3. Okay, I'm also going to fill in the table here so we don't have to come back to it. First of all, though, we need to know that this is y equals 2 cos 3 x minus 2 pi over 3. So we have to factor out that 3. And then we can say that our amplitude is 2. Our period is 2 pi thirds. Our vertical translation is up 4. And our phase shift is right 2 pi over 3. Let's look at these. These are some pretty hefty graphs here. And again, I'm going to draw it the same sort of way. So I'm going to think about just drawing a sine curve and then labeling the things I need to know. So this 2 down here tells me my principal axis. I'm still going to draw it in the middle, though. Just label it as -2. And then I know that I need a maximum value to be 6 up from that. So 6 up from that is going to give me a maximum value of 4. And I can also put in this line to help me. So 4, let's see, did I actually count that right? 1, 2, 3, 4, 5, 6. Oh, I did. 1, 2, 3, 4, 5, 6 is going to be here. So when I go down 6, that's going to be to here. That's going to be my minimum line. That's -8. Okay, now these other things I'm thinking about to help me label my x-axis. So my period is going to be 4 pi. So a full cycle is going to take 4 pi. And I'm starting by moving left 2 pi thirds. So I'm going to go ahead and just draw my sine curve, try and make it symmetric. So I'm going to start, and last time we went by 3s, so I can do that again. 1, 2, 3, sine goes to its maximum. 1, 2, 3, sine is back at 0. 1, 2, 3, sine is at its minimum. 1, 2, 3, back to its central axis. 1, 2, 3, up to the max. 1, 2, 3, back to the middle. 1, 2, 3, down. 1, 2, 3, back to the middle. So here's my nice smooth sine curve. Okay, I know that this total distance has to be 4 pi. I also know that this leftmost value has to be -2 pi thirds. So -2 pi thirds plus 4 pi. That's going to be 10 pi thirds. And that's how I'm going to label this value. I know that this distance is another 4 pi. So I'm going to add 4 pi, so that's another 12 pi thirds that I'm adding. So I can label this one as 22 pi thirds. If I want to label this value, it'll be adding 2 pi. So that halfway point will be adding 2 pi. -2 pi thirds plus 6 pi thirds, that would make this bit 4 pi thirds. Okay, so I can see that my total distance between these is 6 pi thirds. That is, does that make sense? That the total distance is 6 pi thirds? Right, because of course the total distance between them is 2 pi. So this value here is going to be, just if I add pi, that's going to be pi thirds. So that means my y-axis is here. My x-axis is up 2 from the principal axis. So I've got my x and my y. And I really do draw those things last. All right. So if you haven't been pausing yet and you've been just sort of drawing it along with me, really at this point you should pause this and try and draw it and then come back and see what it looks like. Okay, so pause it, try and draw it yourself. Do it on scrap paper if you want, and then come back and look. All right, so hopefully you've unpaused. As we said before, I'll just write it out here. We've got our amplitude of 2. We had our period of 2 pi thirds. We moved up 4, and we moved to the right 2 pi thirds. Okay, so up 4 means my central axis, my principal axis. This is at 4. I'm going up 2 from that. I'm going to count 2 spaces as 1. So up 2 is my maximum. I'll label that 6. Down 2 is here. And because it's easy for me to think about, down here is going to be my x-axis. Okay. Cosine starts at its peak, so it starts up top and then comes down. So I'm gonna go ahead and draw that in, and I'm gonna shift it, just knowing that it's shifted to the right. I'm gonna shift it, start it shifted to the right, so, and again, I'm gonna count by threes. 1, 2, 3, to the middle. 1, 2, 3, to the minimum. 1, 2, 3, to the middle. 1, 2, 3, to the maximum. 1, 2, 3, to the middle. 1, 2, 3, to the min. 1, 2, 3, to the middle. 1, 2, 3, up to the maximum. And again, I'll try and make a smooth curve. And now I'm going to think about my x-axis labels. So I know that I've moved to the right 2 pi thirds. I know that my total period from here to the next peak is also 2 pi thirds. 2 pi thirds plus 2 pi thirds is 4 pi thirds. So I can label this 4 pi thirds. Halfway between those is pi, 3 pi thirds. Add in another 2 pi thirds, and I get over here to 2 pi, because that's going to be 6 pi thirds. And here we've got 5 pi thirds. Okay, so I can see that every 1, 2, 3, 4, 5, 6 lines is 1 pi third. So I need to go over 12 lines to here if I want to draw in my y-axis. So I still didn't plan it very well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Down over there would be my y-axis. So that was not very well thought of. And that's really because my period is so short. So right now I've got 6 lines to give me a third pi. So another 6 would be 1/3 pi, another 6 would be 0. All right, hopefully you came up with that too. And I'll see you in class.